On your IP page, title it Wave Energy Notes, set it up to be Cornell or Avid style, and at the top, write the essential question, which is, what is the relationship between wave properties and wave energy? Another way of saying relationship is like looking at a connection between the properties of the waves and the energy that it takes to make the wave move, and also the energy that is transferred. Here's just a quick review of the properties of the waves because we're going to be discussing them today. Remember that amplitude is the distance between the resting line and the crest or trough, and basically it's the height of the wave. The wavelength is the distance between crests or troughs, the distance between full cycles, and the term frequency has to do with how many crests and troughs really we have per second in a given amount of time, because frequency describes how many cycles we have per second, and of course it's measured in hertz. So if we have a low frequency in the same amount of time as something that has a higher frequency, then this lower frequency wave will have less crests and troughs than a wave with higher frequency in the same amount of time. So here's what really needs to go into your notes. Remember that all waves have two things in common. One is that there's always a back and forth pattern of motion, and there's always a transfer of energy. Now, there are two main types of waves, mechanical waves and electromagnetic waves. The difference is that mechanical waves need a substance or a material to travel through, and that material is called the medium. So for mechanical waves, they need air or water to travel through. Electromagnetic waves do not need a medium, like visible light, radio waves, microwaves, X-rays, UV rays. They don't need air or water to travel through because visible light can travel through outer space where there is no air. However, sound, which is an example of a compression, also known as a longitudinal wave, needs air or water, some kind of medium to travel through. Transverse waves are also mechanical waves, and another type of mechanical wave is a surface wave, like an ocean wave or a seismic, also known as like an earthquake wave. Going back to also the definition of energy, this is the ability to do work. Remember that energy cannot be created or destroyed, but it can be transferred from one place to another or from one form to another. So going back to this example of a ball that might sit in the ocean waves, the ocean waves have crests and troughs, but even though the wave motion is moving forward, the ball will stay typically in the same place. It'll just move up on the crest and down the troughs. This is because the energy is being transferred, but the water molecules are basically staying in the same place. So think about this. As we're talking about energy and one property, amplitude, if you were to take the slinky and you were to make it have higher amplitude or lower amplitude, which one would need more energy for you to oscillate or vibrate that slinky back and forth? If you were to add more energy, like move faster and faster and faster, not necessarily faster, but you add more energy to your motion, you will notice that your amplitude may be higher. Here's a relationship between amplitude and energy. High amplitude waves have more energy than low amplitude waves. It would take you more energy to make higher crests and troughs if you were moving the slinky. So we would say that amplitude and energy have a direct relationship. That means that they increase or decrease together. Increase energy, increase amplitude. Decrease energy, decreased amplitude. Think about the same kind of idea as it relates to the frequency of the waves. What if you wanted more crests and troughs? Would it require more energy for you to move the slinky to have more crests and troughs, or less energy? As you think about the relationship between frequency and energy, this also has a direct relationship. The higher the frequency, the higher the energy that's required and is being transferred. The lower the frequency, meaning the less crests and troughs, means you need less energy to make it happen. So the direct relationship is increased energy, increased frequency. Decreased energy, decreased frequency. These two go hand in hand. They have a direct relationship. But here's where things get a little bit trickier. When we consider the wavelength of a wave and the energy, these two have an inverse relationship. This means that they increase or decrease opposite of one another and also proportionate to one another. So here's the thing. We automatically affect the wavelength if we affect the frequency. Think about this. In the same amount of time, let's look at this picture right here. In the same amount of time, if we have 1, 2, 3 full crests here, let's count this one, and this one, we would say that the frequency is 3 hertz. This only has 1 crest, so we would say it has 1 hertz. Now, the wavelength, then, the space between the crests, is obviously longer than the space between the crests here, which means that when we have a high frequency, we have a short wavelength. When we have a low frequency, the space between crests is longer, so we have a longer wavelength. This means that the relationship between wavelength and energy is inverse to each other. Because when there is high frequency required by high energy, then the wavelength is less. But when we have decreased frequency, which requires decreased energy, then we have an increase in wavelength. Remember, high frequency takes more energy, but that means we have a lower wavelength, short wavelength. Low frequency requires less energy, but that means we have a longer wavelength. So wavelength and energy have an inverse relationship. So now that you've gone through all of these notes, make sure that you have at least 3 questions and a summary to answer the essential question. When you're finished, you will start your output page that shows me that you understand the notes. On the OP side, title it Wave Energy Quadrants. Quadrant 1 will be titled Energy, Quadrant 2 Mechanical Wave, 3 Direct Relationship, and Quadrant 4 is Inverse Relationship. Remember that when you're doing quadrants, each quadrant must have the term, a detailed description of the word, and a colored diagram, picture, or some kind of visual to show us what that term actually means. If you need additional instructions on how to do quadrants, please see OP6 in your science notebook.